introduction, though, is around cloud service models. For us to understand where we're really going in this topic, we're going to discuss today. The first thing we have to understand is that cloud is not a destination. It is in and of itself a service and delivery model that I can deploy in any data center I want to do business, whether that's public cloud, private cloud, which is just another name for my own data center, and hybrid cloud, which is something in between the two, right? So let's internalize that cloud is not a destination, it's a service and delivery model as we go through this, and everything will make a little more sense, I think. So talking about that, let's go through a little bit of history. 20 years ago, we were all deployed largely on physical systems with usually an application per server, and we discovered that there was a lot of stranded processes, a lot of stranded cycles, clock cycles on CPUs, stranded bandwidth on network connections, stranded storage on internal hard drives. And it was just very, very inefficient. We brought along virtualized servers, initially by VMware, but a number of other companies have joined in, to make that a lot more efficient, to be able to virtualize servers on top of a physical server, to be able to use up those stranded resources, right, and become a lot more efficient. In the process, we created some other efficiencies, the ability to move workloads via vMotion or other technologies such as that from one data center to another, or one virtualization cluster to another. And over the last few years, there's been a lot of talk about moving that virtualization down yet another level to the actual application layer, and breaking apart all the microservices that make up an application, and being able to, actually check the common ones like email services or backend storage communication or things of that nature into a library. So anytime we're building a new application, we can check out maybe 70, 80, 90% of our application from pre-developed microservices, and only have to custom develop a couple to make our application unique. And this is what creates a lot more speed and a lot more customization in the environment as we move forward. And that's exactly what we want in a world that's moving at a faster and faster pace every day. So a lot of companies are playing with this right now. And I want to stress this. There might be some of you sitting out there thinking, oh, wow, I'm way behind. You're probably not. One of the things, and this is my experience, but I'd say probably 70 to 80% of the companies that I talk to are playing with containers. Maybe they have in a lab somewhere, but only 10 to 20% are in production, and most of those aren't really happy with their production deployment. And about 20% aren't even playing with it right now. The ones who are playing with it are playing with it for a variety of reasons. They're looking for improved time to profit, improved time to deploy, new solutions, frankly, a way to compete with some of these born in the cloud companies that built their solutions from the ground up using a lot of these services. The ability to quickly capture new businesses, cloud enabling some of our legacy workloads. But ultimately, this is about better control of our financial and human capital investments, so it can be a lot more efficient in the market going forward. So I mentioned about 20% of the people weren't even playing with it yet, and you might wonder why. Well, it's the hurdles that we're going to talk about here in a moment that keep them from moving. They realize this is a completely different architecture, even in a lot of ways, a completely different way of thinking. For example, I was talking to a guy the other day who it really clicked on in his brain. He said to me, he goes, oh, so I need to move from a crash-proof mentality to a crash-resilient mentality. And I said, absolutely. By and large, we used to architect systems based on how much uptime we could get. And now, generally speaking, although there's exceptions to every story, we architect those solutions for the cloud on how quickly we can get them back if they do crash, right? Think of it the way you think about your cell phone. There are applications on there that crash all the time, but if you come back within a second or two, who cares? This is kind of the cloud mentality going forward. The big thing to understand here is that we have solutions to mitigate these second thoughts, and even to get you off the fence if you're playing with it and would like to get into production, to really take advantage of these technologies and start moving to the next phase of IT. So what is the problem? The problem is this is really complicated, and not the container environment itself. The container environment itself, any competent 15-year-old can install the software. But to harden that software for production, you need to put around that container environment a lot of these bubbles we have listed here. These are called operators in a container world. And the problem is most of these need to be custom developed, things like security, high availability, disaster recovery, backup and recovery, persistent storage and memory, governance. A lot of these were never thought of when the original container environments were built. They're not included in the base container environment. Even some of the ones that are, like orchestration, those all need, they need some customization for most production environments. This creates a cycle where a lot of companies are rolling their own and spending up to 24 months to get a production ready environment. It's a problem, right? So how do we overcome that? Well, one of the ways we do that is by looking at the right container environment to begin with. And there are a lot of options out there. But we've standardized on a solution that uses Red Hat OpenShift as the engine. And there's some reasons we did that. First of all, they are a well-represented solution in the marketplace. At almost 50% of the market, they are a significant portion of the market. And candidly, we're kind of betting on Kubernetes to beat Docker because that's the way things look like they're going. And OpenShift by Red Hat to be kind of at the top of that heap because that's the way things are going. And they don't look to be slowing. Red Hat at almost 50% of the market is actually double its closest competitor, which is assembling a whole bunch of open source bits and rolling your own, which is highly problematic and highly manual, right? The other off-the-shelf solutions are roughly a tenth of Red Hat's market penetration at best. Red Hat OpenShift is also the only one today from an off-the-shelf, from a private or hybrid cloud standpoint, that can be deployed on bare metal. This is important because as we scale and as we introduce high performance workloads, eliminating that virtualization layer as much as possible, being able to run those workloads directly on the underlying hardware is going to be critical as we grow, as this takes over the world. You know, if we're 5% of our enterprise, that's not a big deal. Once we get to 75, 85, 95% of our enterprise, this becomes a very, very big deal. Red Hat's also the only one that offers a solution that needs no third-party software to be complete. With the solution I'm about to share with you today, it becomes the only solution that works equally well in public, private, and hybrid cloud environments. So what is this solution? IBM has partnered with Red Hat to deliver IBM Storage Fusion. And what IBM Storage Fusion is, in a nutshell, is the most common deployment of every single one of those operators around an OpenShift container environment, so you can immediately deploy into production. Now, immediately, what does that mean? I like to say we can have you in production in 45 days. That's 30 days to deliver the equipment and software and set it up, another 2 weeks to kick the tires, and you can deploy in production if you want. Now, this is a big deal if you consider that comparison to the 2 years it might take you to get into production that I talked about earlier. This is actually very, very common. And I'll show you some wins later on in this presentation that candidly, all of them, if you boil it down to the bottom line, came down to we bought Fusion because we could do it now instead of a year and a half or 2 years from now, right? So what does that buy you? Well, doing containers is actually very, very hard from a production standpoint for a variety of reasons. Just give you a couple, like from an operations standpoint, how do I build an environment that's actually predictable and supportable? Especially when we're rolling our own and doing so much customization. The developers know what's going on, but how do my guys, feet on the ground know how to support this day in and day out? OpenShift really standardizes that, makes that very simple. It allows you to design, deploy, and maintain your infrastructure in a way that you can expect applications to run efficiently and reliably. It's got a host of capabilities that are really centered around all those operators I spoke about a little bit ago, but allows you to consolidate and centralize management. For example, orchestration's built in, which means any place I deploy Fusion, I might do business in 5, 10, 15 data centers around the world today. If Fusion's in all of them, then I can log into any one of them and administer all 15 environments. That's just one example. But then all of that standardization comes with a number of benefits to the clients that use it. You can reduce your total cost, you can increase your productivity, reduce risk. And my favorite is if you've got revenue generating applications you'd like to get into production, you can radically reduce your time to profit. So let's talk about some of the use cases then that are available in container environments, Fusion to be specific, and why it's so good. And the one I want to focus on as an example is data and AI. And in order to talk about data and AI, the first thing we need to talk about is the data. So again, if we look at a history of how we manage our data from this standpoint, back in the 90s, we were dealing with data warehouses that were just basically a big data sink where we could go in and run queries against it and do some analysis. But, in the 2000s, we needed a little more intelligence around that. So we developed data lakes, but they were limited in their performance, expensive to maintain. So we kind of went to a cloud data warehouse, but those were highly customized by different vendors, had lock-in and high costs, had limited AI and ML use cases. So now what we're seeing in container environments is what they're calling a data lakehouse. And a data lakehouse takes all the best qualities of all of those 3 prior implementations and adds customizable granular metadata tags, for example, and different things of that nature on top. So we can actually curate our data in a much more intelligent manner. Because of that, we can run ML runs or BI runs or things of that nature against much smaller, more accurate data sets, and then change those learnings or the value we're getting back out of the data in a BI instance from weeks or months, or even if we're highly efficient, get it from days to hours. And this is really critical in the environment today because that data intelligence does us no good if it's aged to the point that it's not useful anymore. So then what does that actually look like? So IBM's AI is Watson, and they have a deployment of that for container environments called Watson X. As it stands today, Watson X has 3 major components. The first is Watson Data, which is that Watson-based data lakehouse we were talking about, and it is deployable on IBM Storage Fusion as we speak. By the end of this month, the actual AI engine for Watson will be deployable on Fusion. And the third major piece, governance, which controls, how we manage our data, how we react to different regulations, things of that nature. That will be included by what I'm hearing is mid Q1, but certainly by the end of first quarter next year. So by, say April 1st of next year, we can have a comprehensive business-oriented AI solution on our container environment. And this is a container environment that runs on bare metal, so we don't have the performance issues, and can support things like GPUs so that we can get the performance out of these high-performance computing solutions that we need. So that's one example of how Fusion is not only built to get you off the ground in production, but really to scale with you, not only on the number of container applications you might use, but on those highly performative applications you might want to run. Watson has a number of other sub applications within it, things that that provide a lot of extras. Most of these that are listed on here are actually free of charge. The three major ones at the top certainly cost, but most of the ones underneath are free of charge and just add whatever features you might need. And I think you'll find if you investigate this a little bit, it really gives you a comprehensive business style AI that is going to be far superior to anything you could do with some of the common ones we're hearing about today, like ChatGPT or things of that nature. So this is what the capabilities are. Let's talk a little bit more about the platform and the software itself. Today, IBM Storage Fusion is available on a number of platforms. The two most common, the two that have been supported for over a year now, are software defined, and there's an HCI deployment that is based on x86 servers. This hyper-converged solution is literally a fourth platform data center in a box. So if we understand that the client server paradigm was kind of the third platform, what we've been running on for the last 20, 25 years, the move to a cloud-centric service and delivery model is an inflection point worthy of being tagged a fourth platform data center. So if you think about it from that standpoint, an HCI Fusion deployment is a fourth platform data center in a box. So while we've just kind of shown how it can run your most highly performative use cases, this means this system is designed to eventually migrate every single use case in your data center into this type of deployment. And while we're showing a single rack here, this can actually be deployed and clustered into multi-rack deployments. So it can grow with you pretty much as large as you want to go. What is interesting is that coming out this month is a new version of the Fusion software that's going to add support for multiple other platforms. But the one I want to focus on specifically is IBM Power. IBM Power scales quite efficiently and is capable of things that the x86 platform isn't. For example, in a Power platform, I can actually virtualize. But because the virtual systems in a Power environment are actually tied to the physical capabilities of the server itself, not a virtualized abstraction layer in the operating system, then I get both the benefit of being able to subdivide my server into multiple virtual servers, but also all the benefits of doing that in a bare metal type of deployment. So I do get the best of both worlds. Also, Power VM, that virtualization layer, is done at that physical hardware layer. So you get, when you deploy a core, for example, on an IBM Power virtualized node, or what they call LPARs, this is actually a physical core, not a virtual core. So you get all the speed, all the multi-threaded capability, everything of that nature. that you would on a physical box. Not only that, with the risk-based architecture, you get a much more efficient architecture than the x86 platform gives you. So you can actually consolidate a lot more on this box than you could, say, an HCI rack of servers. And not only that, but each of those consolidated virtual nodes on an IBM Power environment is much more performative than a comparable x86 server. Better integration with enterprise storage, and you get the idea. Power is simply a lot more efficient. And I want to show you how that actually plays out in your day-to-day decisions in a moment. But what this leads us to at Tectrade is we're at the point that we feel very comfortable recommending in general. Now, certainly this software and these platforms are very versatile, very capable. But generally speaking, we think most clients are going to run Power with Fusion running on it in their core. They'll want the hyper-converged option probably at the edge or in robo offices. And they'll want to run software-defined in the cloud. Now, does this mean they can't make different choices in different locations? Not at all. But we feel these are the best ways to leverage the best capabilities of all of these systems as they sit today. So, we can talk about this later, one-on-one, as we talk about your needs, but I think you'll see basically the same thing. And a lot of that has to do with this story. So if we look at the cost of a container environment over the course of a year, there are a number of ways we can do this. We can use cloud native tools or our favorite cloud provider, and we've picked AWS because it seems to be the cloud provider of choice for about 60% of the companies out there. And as you can see, and these are all comparable environments as far as capabilities, how many applications they can run, how many users can log into them, things of that nature. Using AWS native tools, the cost of this environment is about $870,000 a year. And this is an environment approximately equivalent to about 20 nodes in that HCI x86 based environment I was showing you a moment ago. If we built that environment from scratch, not using Fusion software, but using the Fusion operators to avoid the development time, building that, kind of rolling our own, which most companies are doing right now, on-prem is still about a $750,000 proposition. Now, deploying IBM Storage Fusion on the IBM Power 10 platform with IBM flash storage associated with it, even if we add $100,000 in professional services for IBM to hold clients' hands to make sure everything goes perfectly, still absolutely blows the others away from an ROI standpoint, to the tune that for less than $500,000 a year, we can give you the same capability on-prem. So if we think about that, then that not only has financial implications, but that's, a big piece of this is power and cooling, which plays very, very well if you've got a sustainability or an ESG initiative at your company, for example. So all of those factors kind of combined, the physical capability, the financial benefits, the sustainability and ESG of it all, if you will, all of that plays into what we think will be IBM Power as the go-to environment for on-prem or private cloud deployments here in the near future. And this is a solution that's going out to some of the largest companies in the world. Unfortunately, I can't name them by name, but I can tell you that we have a variety of different kinds of companies looking at this. For example, we see a telco in North America, a healthcare provider, a European bank. On the next page, I've got a variety of different financial services institutions. We're seeing insurance companies, we're seeing manufacturing. Manufacturing, by the way, really loves this solution and really buys into the core edge cloud standpoint, because what you'll find in manufacturing is a lot of them do have data centers, but a lot of them have highly sophisticated computer solutions actually running the equipment out on the manufacturing floor. And a lot of that's starting to become containerized now. And what isn't, they'd like to. So having an environment like this to play with would be good. And then certainly there's a public cloud element. So what you're seeing is people all across multiple industries, very, very interested in a solution that can take them to a production deployment in a couple of months instead of a couple of years, right? So where does Tectrade come in then? The value that we really add at the end of the day is around managed services. So we're very, very familiar with this IBM Storage Fusion solution. And what we're capable of doing is augmenting your staff by managing the deployment of Storage Fusion wherever you want to deploy it. So what we do, generally speaking, is manage the Fusion software itself and the underlying hardware that it lives on. So all you really have to do is, whether you bought them off the shelf or developed them in-house, bring your applications and run them, or use our Fusion deployment as your development environment, or any combination thereof. So we'll do things like the system administration, administering the nodes, keeping the software up to date. We do, the service on anything that needs to be serviced. We can, for a small fee, take care of all your backup and restore for you, but we'll generally at least back up the core system so that if anything happens, we can recover it quite quickly. We'll do the configurations on the HA and DR, things of that nature, and certainly storage, monitoring, and logging, things of that nature. So in a nutshell, what we can do is not only get Fusion on the floor for you, but make sure that it is handled with the best possible uptime. With a multi-node environment, candidly, it should be zero downtime. Any node that needs to be worked on could be handled while the rest of the nodes are up and keeping you in business. And certainly we have the capability to make sure all of this is sustained and kept current for you, to the point where even if we were running on Power 10 today and Power 11 came out under our managed services agreement, typically you wouldn't even be charged for the upgrade when we chose to do those. We can talk about that more in detail as time goes on. So kind of where I'd like to end up before we jump into the Q&A here is, if you remember the old Prego commercial, and I'm probably dating myself, some of you with less gray hair than I have may not remember, but Prego was a spaghetti sauce that was available in the supermarket, may still be. I don't know. I don't do the grocery shopping in my household. But they had a commercial series back in the 90s, I believe it was. And their tagline was, "It's in there." And they had an Italian grandmother sitting around with an array of ingredients spread in front of her, and her son sitting across the countertop from her saying, "What about the oregano? It's in there. What about the tomatoes? They're in there. What about this? What about that?" It's all in there. And that ultimately is what Storage Fusion is for us. All the things that we need to have a successful, supportable, hardened production environment. It's all in there. So as an introduction to, well, and I should wrap up with this statement as well. So we talked about application modernization. To me, going forward, if cloud is a service and delivery model and not a destination, then I would make these bold statements. Number one, I think container environments more and more are going to become synonymous with cloud. And part of the reason cloud has worked only sporadically up to date is because we've been trying to lift and shift third platform workloads directly to the cloud, the public cloud, rather than deploying on a cloud-ready environment like a container environment in the first place. This is why IDC reports things like 40% of workloads deployed to the cloud over the last 2 to 3 years will be repatriated on-prem this year. This is because they weren't cloud ready to begin with. And we need an environment like this to be able to do the application development that we want, to do the application modernization of legacy applications that we want, so that we can deploy them once and they'll stick. But also so that we can take advantage of what's best for our company, so that if our data and AI deployment works best on-prem today with what's next, great. If next year it works better in Google, with a couple of clicks of the mouse, we can move it. If the year after that it works better in the IBM cloud, with a couple of clicks of the mouse, we can move it. If 3 years from now there's a new solution out, a new cloud out that's bigger and better than everybody, we can deploy Fusion on that, and with a couple of clicks of the mouse, take advantage of what it has to offer. That ultimately is what this is all about. All the promises of cloud come true when we standardize on a fully capable, production-ready container environment. Thank you very much for your time today. I'd be more than happy to answer any questions that you have. Brett, back to you.
Hey, great. Thanks. Great job, Phil. Thank you for making a complicated subject very simple. In fact, the way you laid it out, it actually turns out it's not as complex as I thought. So great job. Thank you so much. If any of you have any questions, if you could just enter those into the chat window or the Q&A panel, we'd be happy to answer those now. Phil, there are a couple of questions that had already come in, so I'll go ahead and read those to you here. And then for those of you that are on, if you'd like to ask additional questions, please feel free to enter those now. So one of them said, 2 of my engineers are involved with containers today, but to date, we have no applications in production. How difficult is it going to be for my team to fully exploit containers in production?
Well, so let me answer that this way. Getting to production before today was the hard part. I think you'll find over time that a well-developed container environment is actually easier to manage and maybe more efficient to manage than the current point solutions we have all over our data center today. You'll do a lot more application support in the future than server support, for example. Now, there are going to have to be people that manage the environment properly, people that understand container architecture and can make sure that all the tools and resources are in place for the application managers and developers to leverage. But generally speaking, we will need fewer networking people, fewer storage people, and more container people, right? So those 2 people that you've got are probably a good place to start. But I'd probably make them maybe platform engineers or architects. We can talk a little bit more about what that role looks like in a managed service environment like Tectrade offers. There'd be a lot of collaboration between them and us on how we want to deploy your environment, how we want to leverage the things we do deploy. And then you'll probably grow that team over time, but 2 is probably a good place to start.
Okay, good answer. The other question here is, my company's lagging as it relates to modernization and making the move to hybrid cloud. We're still about 90% on-prem. Does Fusion offer ample value for my on-prem environment today? And what additional investments do I need to make to move to hybrid cloud in, say, a year from now?
So a couple of things. Number one, if you are actually running 10% of your workloads in production, I don't care how big or small they are, you're not behind. You're actually ahead of the curve. Unless it's a born in the cloud company. Very few companies have 10% of their workloads in the cloud today. Now, you might be somewhat disappointed in your results. If you're like most companies that have up to 10% of their workloads in the cloud, I would hazard a guess that most of those were, like we were talking about before, third platform workloads that were just lifted and shifted, and your mileage is probably varying on what happened there. So what I would say is that a lot of those are going to have to be repatriated and redeveloped to some degree, whether it's just adding a couple of simple things so they can stick in the cloud, or maybe a complete rewrite or somewhere in between. You need a good container environment to do that. And you need a good container environment to do that is supportable in production as well. So I would say Fusion is absolutely the right answer for that, both as a well, I guess you can do OpenShift as your development environment and Fusion as your production environment or environments, and then everything just works together seamlessly, right? I'd want to meet with you at some point and talk in more detail about the specific challenges that you're facing. But I would say that what you would see if you invested in and deployed Fusion is that you would see probably about the same effort to get the next 40 to 50% of your workloads to the cloud as you did to get the first 10, because Fusion is just equipped to do all the things that you need to do.
Okay. All right. On the heels of that, I have various workloads with some being very performative. Can Tectrade help me determine which ones I should keep local and which I should move to public cloud?
That kind of consulting service is one of the things that we do for our clients every day. So we tend to specialize not only in managed services, but also on high performative, highly complex, highly regulated workloads. And because of that, there are some very difficult decisions to be made on, do we leverage the public cloud for this? Does it have the governance and the security that we need for some of the critical data that I might be using here? Or is it better to keep on-prem? And if I keep it on-prem, do I have a cloud service and delivery model type of infrastructure here that I can run it on, right? So these are absolutely the questions we'll wrestle with together, and that we can help you make the best decision. But I would also say that the critical thing to remember here is that none of those decisions are permanent. We can make the best decision we can today, and in 6 months we could find new information or gain new experiences that prove that something else might be better. So the other big deal about all of this is the orchestration bit that makes it so simple, comparatively speaking, to move a workload from the cloud, the public cloud, back to on-prem, or from on-prem back to the public cloud, or like in a case like what Tectrade does, where we'll take your systems, we'll move them to a nearby colo, manage them for you. And that's most often in a lot of cases what people are referring to when they're talking about hybrid cloud deployments as a point solution. We can help with that as well. So literally any of the 3 data centers you might run, types of data centers, I should say, that you might run workloads in, we are absolutely the safe pair of hands that can help you get from here to there.
Okay. Let me check and see if we have any more questions here. It looks like that's it for now. If anybody has any additional questions, feel free to type those in. And with that, if we don't have any other questions, I'm going to go ahead